In this video, we are going to learn about the different types of giant chemical structures and link these to their properties. There are three main types of giant chemical structures. Sand, graphite and diamond are examples of giant covalent structures. The arrangements of the atoms can be quite different. Sand contains silicon atoms covalently bonded to oxygen atoms. 4 oxygen atoms are bonded in a tetrahedral arrangement around each silicon atom. Diamond has a very similar structure, where all of the carbon atoms are joined by covalent bonds in a tetrahedral arrangement seen here. In graphite, the carbon atoms are arranged in hexagonal sheets and have intermolecular forces holding these sheets together. These layers peel away when our pencils make a mark on paper, because the forces holding the layers together are intermolecular and are quite weak. So when you are writing with a pencil, you are actually transferring sheets of carbon. Seeing as all of the atoms are joined by covalent bonds, these materials have very high melting points. Diamond is one of the hardest substances in the world, but graphite is quite soft. The structure of these materials also determines their electrical conductivity. Diamond does not conduct electricity at all, because its electrons are locked up in covalent bonds, whereas graphite contains 3 electrons and so can conduct. Silicon is found in semiconductors, and it is through adding other elements, called doping, that it allows partial conductance, which has applications in computing. Table salt, sodium chloride, and magnesium oxide are examples of giant ionic lattices. Ionic bonds are the electrostatic forces of interaction between oppositely charged ions. This cross-section of sodium cations and chloride anions extend all the way for an individual salt grain. It's a similar scenario for magnesium oxide.